Example 6, suppose that you know that 42% of the employees of a large computer company are female. Find the probability that a randomly selected sample of 250 employees would contain 90 or less females. Okay, so let me just kind of digest what's going on here. Let me make a random variable. I'll call it x. Let x be the number of females employed at this large computer company. Okay, I know then that the probability of success is 42%, and the number of sampled was 250. Okay, there's actually 3 ways that I know of to actually calculate this. Let's go ahead and go through all of them. Okay, the first way that I know to calculate this is by finding the exact probability. Okay, probably the best way that you can. This will be the most exact answer. Okay, so we know that x is actually a binomial situation then, where n is 250 and probability of success is 42%. Okay, what we're actually trying to find here is the probability that x is less than 90. How you could do this is finding the probability of x being exactly 0 plus the probability of x being exactly 1 all the way up to the probability of x being exactly 90. Okay, remember from Stat 213, how to calculate any of these individually would be by taking n, which is 250, and choosing how many you're trying to find, the probability of success, which is 0.42, to the power here of your x value, and then 1 minus 0.42 to the power of n minus that value. Okay, and you could do this all the way along, getting yourself 91 values, 91 different equations, which would take a very long time, but would give you the most exact answer. Okay, so if you, here's the last one, this would be 250 subtract 90. Okay, so if you were to do all of this, calculate all of these values, you would find that the answer is 0.0308671. I did not actually do that because that would take a massive amount of time. Let me show you how to do it with Minitab. Okay, this should be very familiar for you. It's just a review. Calculate a probability distribution of a binomial. We're looking for a cumulative probability. Our number of trials is 250. The event probability was 0.42, and the value we are looking for, less than or equal to, was 90, giving us this value that I found here. That's the first way and the most exact, and I guess if you have the computer, the best way to do it. Okay, another option that you have here is to use the normal approximation. Okay, for the normal approximation, you want to check the assumptions that either n times p is greater than 5, and also you want to make sure that n times q is also greater than 5. In this case, n is 250 times by p, which is 0.42, is actually 105. So yes, that is greater than 5. The other assumption, 250 times by times by 1 minus 0.42, you get the value 145. Okay, that's also greater than 5. Okay, how to use the normal approximation. Okay, so here it's probably best to first find the middle value here, the value that's in the middle. Again, for a binomial, the expected value, the middle value is always n times p. This is 250 times by 0.42. We just calculated this down here to be 105. Okay, so the value in the middle is 105. Now the only problem with binomials are that they're actually discrete random variables. They're represented by histograms, by rectangles. So this is going to be a rectangle here, 105, and the middle of the rectangle would be the 105. Okay, so that is the middle value. Okay, of course, we want to find the probability of being less than or equal to 90. Okay, so we want to find all of these rectangles up to and including this 90 rectangle. We'll also need, of course, the standard deviation of a binomial, which is n times p times 1 minus p, which is called q, and we take the square root of that. This will be 250 times by 0.42 times by 1 minus 0.42 and divided by, square rooted. And we can find that the standard deviation of this value is actually somewhere close to 7.8. Okay, so these are x values. We can then convert these values into z values, but we have to be careful here. Okay, with the binomial approximation, you always have to remember the continuity correction. This is 0.5 estimate here. Okay, so what we need to do is make sure that we remember that, sorry, it's not working that well. Let me change colors, maybe that will help. Okay, so here what we need to make sure is that we realize that this 90 is in the middle of this rectangle value. And really where we're trying to go is to be all the way to the edge here, which is actually to 90.5, not just to 90. Okay, so with that being said, we can use our z calculation, our normal transformation calculation here, and the value that we're trying to transform is 90.5. The middle, of course, is 105, and we also calculated the standard deviation to be 7.8. This value actually ends up being negative 1.86, and we can find the probability using our z table. To be, of course, 0.0314. I'm not going to show you how to do this by Minitab, because if you had Minitab, of course you would just use the exact calculation. But you can see here that these two probabilities are relatively close to each other. Okay, the third way to answer this question is by using the central limit theorem. Okay, so the central limit theorem, we can calculate this probability here by finding what our sample proportion is. Remember, we said that we wanted at least 90 out of the 250 to be females. This gives us a sample proportion of 0.36 to be females. Okay, so if we're talking about the central limit theorem, here the middle we were told was 42%, that is our p-value, and then the sample proportion, the p-hat, we just calculated to be 0.36. Okay, so we're looking for this area here. Okay, remember the central limit theorem for proportions looks something like this. This is p hat, subtract p over top of p times q over n, and then we take the square root of that. Okay, so these are our p hat and p values, and we want to change them, of course, into z's. The middle, of course, will just go to 0. The standard normal's middle is always 0, but what about this z value? That's what we're going to find here. Okay, so we'll do that. Our p hat here is 0.36. Okay, our p value, our proportion value here is 0.42 divided by 0.42 and 1 minus 0.42, and of course the number of sampled was 250. We're going to take the square root of that. Okay, if we do this, we can convert that into a z value here of negative 1.92. And again, I'll just show you the z table, just because if you had your computer with you, I'm sure you would find the exact probability. In our z table, we could find that this would be a probability of 0.274. Okay, so here we have two ways of estimating. Notice that this isn't actually that great of an estimate. With the central limit theorem, you want to be careful, make sure that this is actually going to be large enough that the central limit theorem is kicking in. Here we've got an estimate, however, though, of 0.274. Also, the other issue here is that we've got rounding, so we can comply to the z table. We also have a way of estimating with this normal approximation, and then of course we saw how to do it exactly.